we're going to introduce polynomials. Okay, what is a polynomial? Well, in general, a polynomial looks something like this. Okay, and these exponents here, n, n minus 1, all the way down to 2. Technically, there's a 1 here. And on this last term here, there's technically an exponent of 0, because x to the 0 is just equal to 1. But those exponents must be whole numbers if I want to call this guy a polynomial. Okay? Furthermore, in order to be a polynomial, my coefficients, which are these, Cn, Cn minus 1, all the way down to C2, C1, and C0, those coefficients can be any real number. Okay, so that's fractions, decimals, pi is a decimal, whole numbers, integers, positive, negative, any real number. Okay, all of these things here that are being added together, the coefficients along with the variables and the exponents, each of these, those are called terms. Okay, now the leading term, this first one here, well, first of all, the way that this polynomial is written is called standard form. And that's because the exponents are in descending order. N is the biggest exponent, 0 is the smallest. So it goes from largest to smallest. And in standard form, if you look at the leading term, which is the one with the biggest exponent, that leading term will give us what's called the degree of the polynomial. So n is the degree of the polynomial. The largest exponent. Okay, so again, a polynomial is something that looks like this, where it's a combination or addition and subtraction of a bunch of terms, where each term consists of coefficients, variables, and exponents, where the coefficients must be real numbers, the exponents must be whole numbers, and the degree of the polynomial is given to us by the largest exponent, which is in the leading term. Okay, so now that we know what polynomials are, let's answer this question. Are these polynomials? The first one, p squared plus 3p squared plus 3p to the 0 power. Well, if we look at this one, and actually this was a typo, I think this was supposed to be p cubed. P cubed plus 3p squared plus 3p to the 0 power. Well, we said that the coefficients need to be real numbers and the exponents need to be whole numbers, right? In this case, both of those check out, so yes, this is a polynomial. What about the second one? 2m squared plus m to the 1/2 plus 3 plus m to the -2. Hopefully you guys already see that this is not a polynomial, right? And why is that? Notice that these exponents here are not whole numbers. My coefficients are fine. They're real numbers. 2, there's a secret 1 there, 3, and there's a secret 1 here. But my exponents are not whole numbers, so I cannot call this a polynomial. Okay, let's look at the last one, e to the t. Well, again, we said our exponents have to be whole numbers. I never said my exponents can be variables. So no, this is not a polynomial because exponents in polynomials cannot be variables. Also, I want to make a note, this e here, that's not a variable, that's the number that is approximately 2.8. Okay, so this is that number raised to the t power. So the e here is not a problem. It's the fact that the exponent has a variable that makes it not qualified to be a polynomial. Okay, So now that we really understand what polynomials are, let's talk about tail end behavior of polynomials. So I want you to take a moment and pause the video and read this box so that you can understand how to determine the tail ends of a polynomial. Okay, so go ahead and pause and read the box, and then when you're done, come back. All right, so after you've read that box, you should kind of understand how to determine the tail end if I give you a polynomial. What I like to do is I like to think of the most simple cases, which are here. The polynomial f of x equals x squared. If you notice, my coefficient is 1, so my coefficient is positive, my leading coefficient. In this case, I only have one term, right, x squared. And so my leading term is just x squared. My leading coefficient is 1, which is positive. And my exponent is an even number. Okay, so if you read the chart above, if the degree is even and the leading coefficient is positive, then both of my tail ends will both point up. Okay? Leading coefficient is greater than 0. Degree is even, so both point up. Okay, in the second example, f of x is equal to negative x squared. My leading term is the only term I have, negative x squared. My leading coefficient is negative. So leading coefficient is negative or less than 0. My degree is even. So since my leading coefficient is negative, my degree is even, then both ends point down. Okay, taking a look at the next example here, f of x is equal to x cubed. My leading term is the only term, x cubed. My leading coefficient is positive. My degree is odd. So leading coefficient positive, greater than 0. Degree is odd. So I have down to the left and up to the right. And lastly, my last example, f of x equals negative x cubed. My leading term has negative coefficient and odd degree. Leading coefficient is less than 0. Degree is odd. So I get up to the left and down to the right. Okay, so these four polynomials here, probably the simplest polynomials, these are the ones that I remember to help me determine how to determine the tail end behaviors. Okay, so now that we understand that and that you've read this box here, let's take a look at a more complicated example. So we're asked to determine the tail end behavior of this function f of t equals 4/3 t cubed minus 4t to the 4th. So we look at the leading term. So notice here, I can rewrite this in standard form, negative 4t to the 4th plus 4/3 t cubed. Writing it in standard form allows me to easily see that my leading term is negative 4t to the 4th power. Okay, so my leading coefficient is negative 4, so it's less than 0. And my degree of my polynomial is 4, so it's even. So because my degree is even and my leading coefficient is negative, that tells me that both ends point down. Right? That's very similar to f of x equals negative x squared. Degree is even, leading coefficient negative, both ends point down. So what does this mean? This is telling me that if I wanted to graph my function f of t, so if I had a vertical and horizontal axis, I might not know what's happening in the middle of my graph, but at the very least, I could tell you that my graph would point down to the left and down to the right. Now in the middle, I don't know what's happening. Maybe it looks like this or something else. I don't know, right? I can't determine that information. But from what I know, knowing that I can analyze the end behavior, I can determine that both of the ends are going to point down to the left and down to the right.